Ladies and gentlemen, we're going to keep graphing polynomials. We're going to have slight variation in the way the problems are set up here on the back, but what we're doing here is pretty much the same thing. So first thing we're going to do, we're going to have to state end behavior, find zeros, y-intercept graph. To find the zeros, I'm going to factor. Okay. So if you see that you have four terms, you're going to find the GCF. This is factor by grouping. So the GCF of the first two is x squared, x plus 1. Bring down your minus sign. Those two have a 4 in common. Remember, it's x plus 1 because you're factoring out a negative 4 times positive. Now I have x squared minus 4 and x plus 1, which I can keep going, and I need to keep going because I'm trying to find zeros. This is dots, x plus 2, x minus 2, and then my third factor is x plus 1. So if I'm finding zeros, I want to know where each of these factors equals 0. So that would be at negative 2, at positive 2, and at negative 1. So on my graph, I know right now I can put dots on the x-axis at negative 2, negative 1, and positive 2. Those are my x-intercepts. I found those by factoring and finding my zeros. I know where it hits the x-axis, but to draw it, you got to kind of think about what the end behavior is going to look like. And since this is a positive odd polynomial, I know it's supposed to look something like this. It's increasing as we read left to right. So it's going to start down here, and it's going to end up there. And since all of these are degree 1 multiplicities, then it's going to pass through all of them. So when I draw it, I can just say, okay, it's going to start down here. It's going to go, oh, I got to put the y-intercept in there too. The y-intercept is negative 4. 1, 2, 3, 4. There you go. Before I do it, I'll put the y-intercept. The y-intercept is right there. So now, I know it's going to pass through every time, so I'm going to go up. It's going to pass through, and it's going to turn around. And then I'm going to just say, it picks this guy up. That probably isn't the bottom, and then it goes back up like this. There's 3 x-intercepts at negative 2, at negative 1, and at positive 2. Since they are all odd multiplicities, they're all degree 1, the function passes through the x-axis all 3 times. I also included the y-intercept in this one, which is the constant term negative 4 on the end. So I've done the zeros, I've done the y-intercept. I need to state the end behavior, so we're going to use limit notation. So the limit of the function is f of x. And I'm going to say when it's x goes to infinity, positive infinity, that's to the right, and the limit of f of x as x goes to negative infinity as we go to the left. So as we go to the right, as x goes to the right, y goes up, so the limit is positive infinity. And as you go to the left, y goes down, so the limit as x goes to negative infinity is negative infinity. Okay? These are the end behaviors that we talked about the other day. So you factor it, and then you describe the end behavior, and then you should be able to sketch the graph. Here's another one. This one is degree 4. So if it's degree 4 and it's a positive leading coefficient, I know I'm going to expect something that looks kind of like a W. But let's factor it and find the zeros. So it's got, well, first always do GCF. That's x squared, and then I have x squared plus x minus 12. And now I'm going to split the middle, so I'll find numbers that multiply to negative 12. And add to 1, that would be 4x and negative 3x. Add x plus 4 minus 3, x plus 4, and my factors will be x minus 3, x plus 4. And don't forget about your GCF, x squared, because that's going to have zeros. So since I'm looking for zeros, I'm going to say, well, when does this thing equal 0? Well, this is a factor, and x squared could be 0. If x squared is 0, then 0 times all this other stuff will be 0. So that is when x equals 0. That is a 0 at x equals 0 right there. Also, I have a 0 at 3, because if I plug in 3, I'll get 0. And the third factor is at negative 4. Negative 4 plus 4 is 0. 1, 2, 3, 4. So those are my zeros. Now I need to draw it, and since I know it's supposed to look like a W, I'm going to start up here. And I'm going to have to kind of think about this before I go. I want to have like a game plan. So I'm going to start up here. I'm going to get to negative 4. That's an odd multiplicity, so I'm going to pass through. And I'm going to go back to 0. And you see this is an even multiplicity. That's degree 2. So I'm going to bounce off this x-axis and turn around. And then I'm going to go back to 3. And since that's an odd multiplicity, it'll pass through. So I start up here. At negative 4, I have an odd multiplicity. It's degree 1. Then I go to this guy and I hit it, but since it's x squared, that's an even degree multiplicity. It's going to bounce off, and then it's going to pass back through, because at these are my x-intercepts. Now, I don't care about where these points are. They might be ridiculous. It doesn't matter. And since the y-intercept is the origin in this one, I don't need to worry too much about that either because it hits 0, 0. So I have my x-intercepts. I have my x-axis behavior. The last thing I need to do is describe the end behavior in limit notation. So this is g of x. The limit of g of x as x goes to infinity. It's terrible. As you go to the right, as x goes to infinity, y goes up, so this will equal infinity. And then I'll do the same thing for the other endpoint. X goes to negative infinity. As x goes to the left, that's what this is saying. X goes to the left, y is going up as well, so that's also positive infinity. Okay. Let's do one more like that, and then we'll do some different ones. So here we've got another problem with, it's a cubic. I'm going to find the GCF. The GCF is x. I have x squared minus 6x plus 9. This is definitely factorable. The numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. So when I factor by grouping, x minus 3 minus 3, x minus 3. Oh, it's a perfect square. X minus 3, which I'm going to write x minus 3 squared times x. Now it's really important that you realize that x minus 3 times x minus 3 is a quantity squared because that's going to affect the multiplicity and that's going to affect the way it behaves on the x-axis. So when I want to find these things zeros, I'll say, well, again, if the GCF is x, that means x could just be 0 because if I plug 0 in, I'll get 0 minus 0, 0, 0 that way. Or my other 0 is at 3. And 3 is a degree 2 multiplicity, which means it's going to bounce off the x-axis at 3. This is a degree 1 multiplicity, so it's going to pass through. So if this is positive odd, it's supposed to look like this. So I'll put my zeros at 0 and 3. And knowing that I'm supposed to start down here, I'm going to go up to 0. It's odd degree multiplicity, so I'm going to pass through, go up to 0, pass through. Then I turn around and come back for more. At x equals 3, since it's an even degree multiplicity, it's going to hit the x-axis and bounce off, which it has to bounce off. Otherwise, if it kept going this way, then it would be positive odd. So I have my x-intercepts at 0 and 3. It bounces off 3 to go back up towards infinity. And now I'll just write my end behavior. So I'll say the limit of, this is h of x, as x goes to infinity. So as I go to the right, y goes up, so the limit is infinity. And the limit of h of x as x goes to negative infinity. So as you go to the left, y goes down, so this will be negative infinity. So that's describing the end behavior. That's starting with the polynomial that is not factored. But I also want you to be able to do one that already is factored. These are probably the easier ones. There's one little trick to them, though. So when I give you this, we're not going to be using a calculator, so I'm going to say forget about the y-intercept. Some of these you'll get like 6 to the 6th power, and then you have to multiply it out. We're not going to worry about that. So don't worry about the y-intercepts, but we do need to find the x-intercepts and then the behavior along the x-axis. So when you get problems like this, you got to be careful because finding the degree is not as easy as just looking at it. You have to think that this is x to the first, this is x to the first, and this is x to the first. I don't want to expand it because that's crazy, like I don't need to. But if I did expand it, you have to realize you would have an x to the first times an x to the first times an x to the first, which will give you an x cubed. And all of these coefficients are positive in the front. So this is a positive odd polynomial. It's going to look something like this. You have to know what the degree is before you can do anything. So I know it's going to be positive odd. It's going to be increasing as I read left to right. Now I'm going to look at my x-axis and say I have intercepts at x minus 1 equals 0 at 1. So I'll put it out right there at 1. X plus 5, the 0 for that would be negative 5. And then 2x minus 3, 2x minus 3 equals 0 when you add divide by 2, so that's 1.5. So right next to it, 1.5. Okay. Since this is positive and odd, I know I need to start down here and end up there. So let's look at, are there any bounces? This is odd, odd, odd. So it's going to pass through every time. So it goes up, passes through, turns around, passes through, oops, okay, passes through, and then it's like, really close, it passes through again. because it's got two x-intercepts within half of a unit of each other, so that's pretty close. I'm going to assume it doesn't go down very far, but not in that time. But the main thing is that you've got your end behavior. As you read left to right, it's increasing. So let's try another one, and then again, you got to pay attention to the degree. This is an x cubed, this is an x squared, and this is an x. I'm just looking at their exponents. If you add their exponents, 3 plus 2 plus 1 is 6. This is degree 6. So if it's degree 6, that means it's going to be an even degree, and since it's degree 6 and a positive, these are all positive ones in the front of x's, positive even is going to look like a W. That's the tricky thing, is if you get that degree wrong, your end behavior is going to be wrong, which I'm going to come back and do the end behavior for this one after I do this. So let's plot our zeros. All right, -1, +3, and +7. Okay, and I've got an odd degree at -1. I've got an even degree at 3, so this is going to be a bounce, and then I have an odd degree at 7, so this will be a pass-through. So starting up here, I go down, I get to -1, and I'm like, that's odd, so it passes through. 3 is odd, so it passes through -1. Then I get to this guy, and I bounce off of it, because it's an even degree multiplicity. That means it bounces off the x-axis. Then when I get to 7, it's odd again, so it goes through, and then I get my end behavior like I needed. It's my W again. So let me write this in limit notation. The limit of p of x equals as x goes to, smarter, not harder. Okay. So as I go to the right, as x goes to infinity, so as I go to the right, y goes up to positive infinity. And as I go to the left, x goes to negative infinity. As I go left, y goes down, so that would be negative infinity. For this one, as I go to the right and as I go to the left, both endpoints are positive, so they both go to positive infinity. Both endpoints are going up because it's positive and it's even. So we've got end behavior, we did our zeros, we're not doing the line step. Okay, we got it, we're good. Let's do 2 more. So let's see, find the degree first. X squared, and then this is x, so if it was x squared, and x, that's degree 5. This is an x to the 5th, so it's again positive odd, it's going to look like that. So if it's positive and it's odd, I know it's going to look like this. Now what I need to do is find my zeros. So I have 1 at 0, because x squared could be 0. 1 at -3, and 1 at +3. That's nice. So if it's positive odd, I'm going to start down here, and at, let's see, work left to right. At -3, I have an even degree multiplicity, so I'm going to go up to -3 and bounce. Then I get to my next one, x equals 0, also even, so bounce. Then I get to +3, and that's odd, so it'll finally pass through, because that's degree 1, that's my pass-through. So my x-axis behavior is it bounces off of -3, it bounces off of 0, and then finally it passes through at +3. One more. Let's find the degree. This is an x cubed, an x squared, and an x. So 3, 4, 5, 6, that's x to the 6th. So this is degree 6, and it's positive, so it's going to be another W. So let's find my zeros. I have 1 at -6, that's right here. I have 1 at -2, that's right here. And I have 1 at +5, that's right there. Since it's a W, I'm going to start up here, and I'll work left to right. -6 is an odd degree multiplicity, so it's going to pass through. Then I get to -2, that's an even degree, so it's going to bounce off. Then I get to +5, and I think it's supposed to pass through, but yes, it is odd, so it will pass through. So I get another W. Let's do my end behavior again. The limit of p of x equals as x goes to, and I'm going to make a couple of these. It's not going to work. Try again. The limit of p of x equals as x goes to, so I can do both. There we go. 2, 3, 4. Okay. So, as I go to the right, as x goes to infinity, y goes up to positive infinity. As you go to the left, as x goes to negative infinity, y goes down, so that is also negative infinity. As you go to the right in this one and the left in this one, They both go up again, so these are both positive infinity. So you need to be able to tell me where the zeros are, which usually involves factoring. You need to be able to tell me the x-axis behavior, which depends on the degree of the multiplicities. And then you need to be able to use limit notation to describe the end behavior. If you can do all that, you're doing pretty well. So be sure to hit that like and subscribe button.